This video discusses radian measure. An angle is in standard position if its vertex is at the origin of a rectangular coordinate system and its initial side is on the positive x-axis. If the rotation of the terminal side is counterclockwise, the angle is positive, while if the rotation is clockwise, the angle is negative. An angle in standard position is said to lie in the quadrant in which its terminal side lies. Angles in standard position having their terminal side along the x-axis or y-axis are called quadrantal angles. In most applications of trigonometry, angles are measured in degrees, but in more advanced work in math, radian measure of angles is preferred. 1 radian is the measure of a central angle which creates an arc whose length is equal to the length of the radius of the circle. Please note that radian measure of an angle is unit-free. Radian measure is preferred because it allows us to treat the trigonometric functions as functions with domains of real numbers rather than angles. In general, if theta is a central angle of a circle of radius r and theta intercepts an arc of length s, then the radian measure of theta is s divided by r. That is, theta equals s divided by r radians. Next, we're going to practice converting between radian and degrees. To convert from degrees to radian, you're going to multiply by pi over 180 radians and simplify. That's because pi and 180 degrees are equivalent, making this a unit fraction. And when converting from radians to degrees, we're going to multiply by 180 degrees divided by pi and simplify. So first, let's convert from degrees to radian. So I'm going to take my 60 degrees and I'm going to multiply it by the unit fraction pi over 180. I can do some simplifying here. We end up with pi over 3 radian. Same process for our next example, negative 225 degrees. We'll multiply that by our unit fraction pi over 180. We can do some simplifying here as well. We'll end up with negative 5 pi over 4. Now let's go the other direction. Let's convert each radian measure to degree measure. Now you'll notice that the directions say write each answer to the nearest hundredth of a degree. It's very possible because we'll be dividing by pi that we get a decimal. Alright, so starting with 5 radian, we're going to multiply it by the unit fraction 180 divided by pi. So you're just going to multiply straight across, divide by pi, put it in our calculator, rounding to the nearest hundredth, we're going to get 286.48 degrees. Next, let's convert negative 11 pi over 30 radian to degrees. Start with our negative 11 pi over 30 radian. Then we multiply it by the unit fraction 180 over pi. You can do some simplifying here. The pi's cancel out as well. We end up with negative 66 degrees. Two angles that have the same initial side and the same terminal side but different amounts of rotation are called coterminal angles. Their measure differ by a multiple of 360 degrees or 2 pi, since that's one complete rotation of a circle. In our next two examples, we want to find the angle of smallest positive measure coterminal with each angle. So with problems like this, we're either going to add or subtract 360 degrees or pi over 2 over and over and over again until we get an angle that falls in one positive rotation of the circle. All right, so negative 26 pi over 5. This is a negative angle, so obviously we're going to have to add to get into the positives. And since this is radian measure, we're going to be adding 2 pi over and over again. So 2 pi as a common denominator of 5 is going to be 10/5. So that's 10 pi over 5. And when we add that, we're at negative 16 pi over 5. So that's not enough. We're going to have to do it again. Adding another 10 pi over 5. It's negative 6 pi over 5. Still not enough. So let's do it again. This time we get positive 4 pi over 5. So there's our answer. That's our smallest positive coterminal angle. Our next example, 1,654 degrees. That one's definitely over one rotation of the circle, over 360 degrees. So here we're going to subtract 360 over and over and over again until we get something between 0 and 360. This one's a lot easier to just do on our calculator. Just put it in and minus 360 until you get a number in between 0 and 360. Our smallest positive coterminal angle, 214 degrees. Lastly, we want to give an expression that generates all angles coterminal with each angle. We run into this later when we're solving trigonometric equations and they want all possible solutions. We end up using this notation, so let's just review it now. Don't make it hard. All you're going to do to get all the coterminal angles is you're going to take whatever your angle theta is and you're going to add or subtract 360 degrees times n. And then we go on to say that n is an integer. That's what this little stuff here at the end means. That boldface Z is our abbreviation for integer. And that weird looking E means is an element of. So we have to say that n is an integer so that we're multiplying by whole numbers. We don't want to be multiplying by fractions of 360 degrees. So an expression that gives all coterminal angles to 18 pi over 4, we're just going to take 18 pi over 4 plus, since we're in radian, 2 pi n, where n is an integer. And that's it. Don't make it hard. For the next example, because it's degrees, we'll use 360 instead. So 210 degrees plus 360 degrees times n, where n is an integer. Now, you may notice that in the original definition up here, I have plus or minus. You can put the plus or minus or not. It's really not necessary to have the plus or minus because if we state that n is an integer, that encompasses both positive and negative counting numbers. So you can put the plus or minus, or you can just put the plus. Either way, it gives us all our coterminal angles.